Welcome to section 7.4. We are starting a brand new topic today. It's called a logarithm. And so I want to give you kind of in this is about area, I want to give you this idea of what is a logarithm, okay? When we start talking about this, a logarithm, and we shorten this to say log, a log is the inverse of an exponential. Okay, so it basically, inverses we know switch x and y, and we'll start talking about that some more, but a log is the inverse of an exponential function. The goal of a log, okay, the goal of a log is to find the exponent. And so in the second half of this chapter, 7, 4, 5, and 6, our goal is to be able to say, okay, what is the exponent that makes something true? And so what we're going to do is start talking about how do logs and exponentials relate, okay? I'm going to start here with this basic information about a log. And I'm going to start with this exponential form and log form because I want you to see how they relate. We looked last chapter and looked at log, or y equals b to the x. Okay, now you notice there's no a, therefore a has to be 1. But this is the equation that we worked with for 7, 1, 2, and 3. And we made our bases different depending on what we were working with, growth or decay, and the value of b changed. What happens is you're going to rewrite this as a log. And the base of my exponent is b, so the log has a little base b of y equals x. And I want you to keep in mind that this is always the exponent on its own because our goal of a log is to find the exponent. And the base has to be the same in both forms. And I'm going to kind of show you a method for doing it. We call it the loop-de-loop method, but I'm going to show you that in a second. There are two types of logs. A common log is log base 10. And I'm just saying, but in your calculator, it just looks like the log of x. So if you don't see a base, then we call it a common log, which means it's base 10. The second one is a natural log, and a natural log is a log base e. And this is a notation that we don't really use. There's another log button on your calculator, and it's this ln button. In this ln, we call a natural log. And I always say it's some European that says logo natural, which is not true, but it's this idea that's a natural log with a base e. Okay, and so if it's a base e, we just say natural log. If it's a base 10, we just say log. And those are the two types of special logs. And so what I'm going to do is I'm going to slide this down a second. We're going to show you how the two forms relate. And so I'm going to start by switching our form. And I'm going to start by doing the loop-de-loop. What happens is we always start with the base. And so we're going to say 2, and I'm going to go across the equal sign to the exponent. This says 2 to the 5th power, and it's like this 2 pushes the 5 up to become an exponent. When I cross the equal sign again, I say equals 32. And to write it from log form to exponential is the easiest. To go backwards makes it a little harder. So let me walk through that one more time. You always start with the base. The base is 2, and 2 goes across the equal sign to push the number up into an exponent, and then crosses the equal sign again to tell you what it actually equals. And we call that the loop-de-loop method. Now, if I go backwards, I'm going to start with my base. And I'm going to say this is log with a base of 1/2. Make sure your base is a small number just below the log. The exponent is always the answer. So it's going to equal -1 because the exponent is always the answer. And 2 goes in next to the log. Okay? And so that's the harder part. But part of your quiz will be switching the forms from log form to exponential form, okay? The reason we switch forms is because in 7.6 we're going to talk about how to solve log equations. In order to solve log equations, you're going to have to switch forms. The other thing is we want you to evaluate these. I'm going to show you without a calculator because your calculator can only do a base 10, a common log, and a base e, which is a natural log. So here's what I'm going to do. I'm going to pretend this is equal to x for a second, and I'm going to do the loop-de-loop method to rewrite. Okay, and so our suggestion here is that you rewrite your logs in order to be able to figure out how to evaluate. Okay, so let's start with the base. 3 to the x. 3 to some power equals 81. And our question is 3 to what power is 81? This might be a play around. Well, 3 to the first is 3. 3 squared is 9. 3 cubed is 27. And 3 to the fourth is 81. So 4 is my answer. What you want to keep in mind, and I'm not sure where I want to put this, but the answer to a log is an exponent. Okay, the answer to a log is an exponent, and that's one of the most important things that we're doing today. The answer to a log is an exponent. So I'm going to do this again. I'm going to set it equal to x for the second one, and I'm actually, there's no base here, but because it's a natural log, I'm going to put a base e in. And I'm going to rewrite it again. E to the x. So e to the x equals, and I'm going to say e to the 3.6. Well, what does x have to be for these to be equivalent? X has to be 3.6. Because then you could say e to the 3.6 equals e to the 3.6. Okay, we're going to go at this again. They get a little harder as we go. 8 to some power equals the cube root of 8 squared. Okay, let's go back to chapter 6 a second and let's rewrite what this means. Well, this is 8 squared to the 1/3 power because the cube root is the 1/3 exponent. If I multiply these two together, then x has to be 2/3. Because if I multiply these together, then what I'm saying is 8 to the x equals 8 to the 2/3, so x has to equal 2/3. Okay, you will need to rewrite roots as exponents in this chapter. So really, chapter 6 is important in what we're doing. Number 4, let me keep going. 49 to the x equals 7. Okay, this one's a little tougher because I go from a bigger number to a smaller number. You can't divide. That's not the idea. But let me work backwards a second. And I'm going to change my color so I can show you how I work backwards a minute. If I look at this, the question is 7 to what power gets me 49? Well, 7 squared is 49. So if I go backwards, I need the reciprocal. And the reciprocal of 2 is 1/2. So 49 to the 1/2 power would be 7 because 7 squared is 49. Now, what's a 1/2 power? Well, the 1/2 power is the same thing as the square root. Do you agree that the square root of 49 is 7? Well, the answer is yes. And that's what we're trying to do. If you go from a bigger number to a smaller number, your exponent is going to be a fraction because you're going to have some sort of root. All right, let me go one more time. 1/4, if I set this equal to x, 2, the x power equals 256. Okay, so our first hint in number 4 was if you start with a bigger number and go to a smaller number, your exponent is going to be a fraction. Okay, if I go from a fraction to a whole number, I'm going to give you the hint that your exponent is going to be negative. The reason it's negative is a negative exponent will switch this from 1/4 to 4 to some power. Okay, so if my x is negative, I'm going to automatically get rid of that reciprocal. Now the question is 4 to what power is 256? And that's going to be a play around in your calculator one, but the answer ends up being 4. 4 to the 4th is 256. It has to be a -4, though, to make this 1/4 be the reciprocal. Okay? So keep in mind, 4 and 5 are obviously the most difficult. Obviously, by far the most difficult. And we're going to be working on these types, but I wanted you at least to see one of each. Okay? Now I'm going to move this over to show you a few little tricks. These tricks are so important because we are going to use them as we go through and solve. So I'm going to leave it here a second. I'm going to take a look at this. Log base anything of 1 is 0. My question is why? In order to be able to tell you why, let's rewrite it. B to the 0 equals 1. Ah, why? Because any base to the 0 power is 1. So if I look at this, natural log of e of 1 says e to some power is 1. What does it have to be? The answer is 0. Okay, it always helps to rewrite it because you're used to exponents, not logs. Okay, why is the log base b of b equal to 1? Why? Let's rewrite it. B to the first power equals b. Do you agree? Well, absolutely. Anything to the first power is always itself. So if I look here, 11 to what power is 11? The answer has to be 1. Okay, same thing. Here we go. B to the x equals b to the x. Now here's the trick that I want to show you. I'm going to change my color so you can see it. You'll notice this base is the same as this base. If the two bases are the same, the log with a base will cancel with the other base and you just get x, which is what their answer is. Okay, so here's what I'm going to do. I'm going to show you this idea because this is so important in what we're going to do later. As you look at this, I'm going to rewrite 27 so I have a base of 3. So log base 3, 27 is the same thing as 3 cubed to the x power. So if I rewrite this, this says log base 3 of 3 to the 3x power because I multiply these two together. All right, let me change color so we can see some crossing out. This log base 3 will cancel with this base 3, so my answer is 3x. Now, if I were to set this equal to x and show you, we would say 3 to, I don't use x, 3 to the a equals 3 to the 3x. So what does a have to be? A has to be 3x. And this is the idea. The shorthand is if the base of the log is the same as the base of the exponent, they cancel, you just get the exponent. The same thing applies in the other order. If the base is the same thing as the base of a log, these cancel and you get x. So if you look at this one, this says 10 and a log with no base is really base 10. So this 10 cancels with log base 10, my answer is 7x. These two are important because they're so going to help us as we go through and evaluate. Okay, so keep these kind of rules in mind. So we've covered two things. What is a log? And how do you switch forms? What are some rules for logs? And the third thing that we're going to see here is how do you find an inverse? And so I'm going to try and find some space here a second. And I'll go just like this. Okay, here's the biggest thing. To find an inverse. 1, switch x and y. Okay, and we did this in part A. And 2, go back and solve for y. Okay. So here we go. First step, we're going to switch the x and the y. Okay, now in this case, we're going to take the whole x quantity and switch it. So we're going to say 2x equals 7 to the y. Now, the only way to get y by itself is to switch forms. Okay, so we first take the whole x quantity and switch it. And the second thing we're going to do is we're going to change forms. Okay, so here we go. If I change forms, I got to go to a log form. If I look at this, it's log base 7 because 7 is the base of the exponent. We said the exponent stays by itself and the 2x goes in with the log. So my inverse, and I'm going to ask that you write, let me add this to number 3, write F inverse. I don't know if you remember this from part B, or I'm sorry, Algebra 2A, Chapter 6, but we want you to write this. If I go, my inverse, what it's saying is my inverse is log base 7 of 2x. The reason I require this is because I want you to tell me that this is the equation of the inverse. If you don't say that, then the question is, was that the original, was it the inverse, what's going on? Okay, so here we go. We're going to start in the second one by switching x and y. X equals the natural log of y plus 6. Now I don't have to take the whole quantity because it's not in the exponent. So maybe I better write that. Take the whole exponent quantity. Okay? I apologize for this coming up. Let's deal with that. Okay, take a look. Let's switch forms. This is a base e because it's natural log. So let's change our forms. E to the x equals y plus 6. Now, how do we get y by itself? Subtract 6. So my inverse, and I'm going to say F inverse, is e to the x minus 6. Okay? So again, we switched the x and y, and then we again changed forms. So when you do the inverse, you're going to have to change your forms. And so this is the first page dealing with logs. And this is going to be a very long video, and I apologize, but this is a brand new concept for us. And I want to show you some graphing. Okay, so here's what we're going to do. Switch to the next page. Okay, and we want to talk a little bit about what's the difference, and let's see if I can somehow get 1 and 2 on the same page. I can't. Okay, we're going to do a little switching around here as we go. But I want to look at example 1, and I'm going to save some of this for in class tomorrow. I'm probably going to save example 3 and 4 for in class, but I do want to do examples 1 and 2 with you to show you how to do a log. I'm going to suggest if you can do this without a calculator, you know how to work with logs. And so I'm going to push you guys this week to really try and eliminate the use of your calculator. If you end up having to, that's fine, but I really want to try and get out of it. Okay? And so here we go. This is a regular log, which means it has a, I apologize for that, it has a base 10. Okay? And okay, so here's what I'm going to do. If this is a base 10, what I'm going to do in order to make my table and graph it is I'm going to rewrite this. And if I rewrite this, I start with the base. 10 to the y, and so I'm going to write this over here. 10 to the y equals x. And we're not used to seeing an equation like this, and that's why logs are so different. And so here's what I want to do. I want to make a table with my x and my y. Normally, we plug in values for x. But as you look at this equation, we're telling you take 10 to the y power. And so I'm going to take my values that I normally do for an exponential, and I'm going to put them in my y category this time. Okay, because normally for exponentials, we pick -2, -1, 0, 1, and 2 for our x's, and we find the values of y. With logs, you do it backwards. You plug in the values for y, and you find the values for x. Okay, so here we go. It's going to feel weird for a while, but just go with me. I'm going to start with 0. 10 to the 0 power, anything to the 0 power is 1. 10 to the first power is 10. 10 to the second power is 100. Let's go in the negative. 10 to the negative 1 is the reciprocal of the first power, so 1/10. 10 to the negative 2 is the reciprocal of the second power, so 1/100th. And I'm going to graph these normal coordinate points like this as we go through. And so here's how it works. I'm going to start with the point 1, 0 because that's the easiest. If I go over to 1 and plot the point at 0, here's my first point. If I go to 10, 1, 10, 1 is like way out here. 1/10 is like 0.1, and I go down to -1. And 1/100th is like 0.001, you get down to -2. And what you'll notice is our curve is going to look a little different. My curve is now going to go like this and come out. Now, my asymptote, as I change colors, instead of being the y-axis for my asymptote, this time it's going to be the y-axis. And so my asymptote in this case is going to be x equals 0 instead of y equals 0. And do I have a y-intercept this time? No, I now have an x-intercept, which is the point 1, 0. My domain, take a look at my x's. X's are still domain even though we plugged in y's. Are any of these values negative? Well, no. Are any of these values 0? No. As we look, so my domain is all reals greater than 0 because my asymptote is at 0, and if I look, I'm on the right side, which are all of the numbers bigger than 0. Where's my range? Well, now I have the negative, I have 0, and I have the positive, so my range is all reals. And what's important about this? Here's the biggest idea about logarithms. All of our information here switches. Okay, domain and range swap. My asymptote and my intercept kind of swap. Instead of being 0, 1, a log is 1, 0. Instead of being y equals 0, my asymptote is now x equals 0. Because they are inverses, the x and the y portions of what we do will switch. And so you're going to get a graph. What I really want you to understand is what is the look of a log and how do I find it. So we're going to try number 2. And again, I'm going to rewrite this. This says 1/3 to the y power, 1/3 to the y. As I cross the equals sign, it equals x. I'm not going to have a y-intercept. I'm going to have an x-intercept now. So let's take a look at this. Instead of plugging in my values for x, I now plug in my values for y. So -2, -1, 0, 1, and 2. And now I'm going to try the values again. Okay, so here we go. 1/3 to the 0 power is 1, because anything to the 0 power is 1. 1/3 to the first power is 1/3. 1/3 to the second power, I square both top and bottom, so 1/9. 1/3 to the -1 means take the reciprocal, so 3. 1/3 to the -2 takes the reciprocal of the 2, so you'll get 9. Okay, so we need to plot our points. We have this point 9, -2, I can't seem to put on my graph. So 3, -1. So 1, 2, 3, -1 is a point. 1, 0 is a point. 1/3 up 1 is a point. 1/9 up 2 is a point. And what you end up finding is it curves like this. Now, where's my asymptote? My asymptote, again, is going to be the y-axis, so x equals 0. My intercept point, my x-intercept is at the point 1, 0. My domain, take a look, all of my values are positive. So all reals greater than 0, because I'm going right of the 0 line. My range, I have negatives, 0, and positives, so all reals. Okay, and I want you to kind of look at it. This, as you're looking at it, this is a growth. If you can kind of see it, it gets bigger as you go. This is a decay, and take a look, you should be able to realize it from this equation. This has a base of 10, so it's a growth. This has a base of 1/3, so it's a decay. And that's what we're trying to get in your head, is everything is going to be interrelatable. And what we're going to do is practice a ton in class. And I want you to feel comfortable doing some of this without the use of your calculator. Okay? What I'm going to do for you is number 3 we're going to put in class. And number 4 we're going to do in class as well. And I'm going to start off tomorrow with those. And then we're going to really seriously be practicing logs, because logs is the hardest part about this stuff because it's brand new. So that's it for what I'm going to show you right now in section 7.4. Please, questions, concerns, anything like that, come and see me, let me know. But again, we're going to be trying to get out of the use of our calculator and understand what does it mean to be a log and how does it work.